Hello, fifth graders. It's Mrs. Tremblay. I would like for you to have your Unit 3 review/test little workbook page packet that I gave you out. And you should already have problems 1 through 10 done for today. You could have done more if you wanted, but I'm only going to go through 1 through 10 with you. And then tomorrow we'll do the same process, but we'll finish the rest of them. And you should be making any corrections to this. So by the time we're done here, any errors that you made, you should fix them and maybe put a little star next to the ones that you'd like to talk about more in class as we're preparing for our Unit 3 test. All right, so for numbers 1A through 1D, without multiplying, use less than, greater than, or equal to indicate how the product compares to the factor. Product just means the answer. The factors are the numbers that we multiply. And with this, you have to remember, if you multiply by something that is less than 1, you're gonna get an amount less than what you start with. And if you are multiplying by a factor that is more than 1, you're gonna get an amount that is more than what you started with. If you multiply by 1, we know that that number stays exactly the same. So let's use that. So it wants to know, is your answer, x, gonna be greater than, less than, or equal to 13/4? Well, I'm looking at this, and 13/4 is being multiplied by 5/8, and 5/8 is less than 1. So when you multiply a number by something less than 1, it ends up being less than what you started with, less than that factor. Now, on the opposite, if we compare x to 5/8, 5/8 is being multiplied by 13/4. And 13/4, that's improper. That's more than 1, isn't it? Yeah, 4 goes into 13 3 times. And that's 12, right? 4 times 3 is 12, and there's 1 left over out of 4. So we're actually multiplying 5/8 by a value that is greater than 1. That means my answer is going to be greater than the 5/8 because that number is being multiplied by something greater than 1. Okay, for 1B, it wants to know x compared to 4/3. So I look, 4/3 is being multiplied by a value that's greater than 1. That means x is going to be greater than 4/3. And now compared to the 6, 6 is being multiplied by 4/3. And again, 4/3 is improper. 4/3 is really worth 3 goes into 4 1 time. And there's 1 left over out of the 3. So 6 is being multiplied by a value that's greater than 1 as well. So x is going to be greater than 6. So when we get our answer, it's actually going to be greater than both of those factors. All right, for 2/5, when x is being compared to 2/5, 2/5 is being multiplied by a value less than 1. That means I have less than 1 2/5. So x is going to be less than 2/5. And we look at the 1/7. 1/7 is being multiplied by 2/5, and 2/5 is less than 1. So x is also going to be less than 1/7 as well. For 1D, x compared to 5/8. 5/8 is being multiplied by 7/7, and 7/7 is equal to 1. So 5/8 times 1 is going to be 5/8, right? X is going to equal 5/8. Now compared to the 7/7, or 1, 1 is being multiplied by 5/8, which is less than 1. So x will be less than 1. And if we already know the answer is 5/8, isn't 5/8 less than 7/7? Yeah, so we know we're right. All right, number 1 down. 9 to go. Number 2, 3 packages of trail mix are shared equally between Alicia and her 4 classmates. So 3 packages of trail mix are shared equally between Alicia and her 4 classmates. So hopefully you're noticing that it's Alicia, that's 1 person, and 4 classmates, so we're talking about 5. I'm sorry that now my dog is deciding to eat her dinner at 5 o'clock in the morning while I record this. My apologies. She really likes to be a part of the lesson. Okay, so each bar represents 1 package of trail mix, right? It says shade the bar to show how much of each package of trail mix 1 person will get. So these are the 3 packages. She's sharing them between 5 people, herself included. So that means that each person would get 1/5 of each bar, right? So we have to cut these up into 5 pieces. They want to see the visual. So to cut up into 5 pieces, I'm going to draw 4 lines. I'm going to do that for each one, because 4 lines gives us the 5 chunks. Do your best to make them equal sizes. I'm not asking you to get a ruler out or anything. It's okay. If this was something that if this was a test, you probably want to get the ruler out and show me. Okay, so it wants to show how much each package one person would get. Well, if there's 5 people, each person would get 1/5 of that, 1/5 of that, and 1/5 of that. Okay, so that's the picture of it. Now part B says, what is each person's share of the 3 packages? Write and solve an equation. Now, we already just said, like, each person gets this 1/5 and another 1/5 and another 1/5, right? So we could say that each person gets 1/5 3 times, right? And if you have 1/5 3 times, 1/5 plus 1/5 plus 1/5, you could put the denominator under like that, or you could just say, well, if I have 1/5 3 times, that is 3/5. So there's one equation. I'd like you to also list the division equation. Okay, so there's a second one that we can do, and that's what we're kind of learning with multiplication and division. Because they're inverses, we can use both operations. What do we do here? Well, we took these 3 packages and divided them into how many pieces? 1, 2, 3, 4, 5 pieces. So what we really did was 3 divided by 5, right? And we learned that 3 divided by 5 is the same thing as 3 times 1/5, because we're seeing, oh, when I cut these up into the 5, I do have 1/5 3 times, and we'd still get 3/5 from that. So what I'd like you to notice is this and this are the same, right? When you change those division equations to multiplication, you're not changing anything. You're not changing the value of it. You're just using the, sorry, I had to let my dog out, of course. She just ate. It's not time to go outside. You're not changing the value of it. We're just using the inverse operation. Okay, number 3. Mr. Walker must equally divide 12 loaves of bread between 7 platters. How many loaves of bread are placed on each platter? Write and solve an equation. So they tell you that he is going to equally divide, right? So we're given the division, so that's what it should be. Now we have to decide, well, what's the order of it? Well, what is the thing he's dividing up? He's dividing up the 12 loaves of bread, right? So that's what you should start with, the 12. And he's dividing it between 7 platters. So 12 divided by 7 is what you should have, okay? And visually, I could draw out the 12, and I could cut them up into 7 pieces and shade my first piece of each one, right? Kind of like our little trail mix problem. So we see that 12 divided by 7 is the same as 12 times that 1/7 of a piece we'd have for each. And 12 times 1/7 is 12 sevenths, and that's improper. 7 goes into 12 once, and 7 plus 5 is 12. That's the difference there, and my denominator doesn't change. Sorry, I wrote it a little weird. 1 and 5/7. So 1 and 5/7 loaves are placed on each. Okay, next page. Number 4. Erin has 1/3 an hour to warm up for her gymnastics meet. She must complete each of 6 different stretches. She spends an equal amount of time on each type of stretch and does not take a break. How long in hours does she spend on each type of stretch? Write and solve an equation. Okay, so let's think about this. She has 1/3 of an hour, right? That's the total amount of time she has. And she wants to do 6 different stretches in that 1/3 of an hour. We want to know how much time she can spend for each one, okay? So let's see here. What operation did you pick? If I want to share, do some equal sharing does equal division. So this would be a division problem. And when you're solving the division, you have to think about what's the thing we're dividing up. We're dividing up the time, right? Between 6 different stretches. So for number 4, you should have 1/3 divided by 6. 1/3 divided by 6. So we have this 1/3 of an hour, and we want to do 6 different stretches. So I want to know, okay, if there's 6 different stretches I can do, how long will each one take? Okay, So in order to solve this, we learned that you can take the 1/3 and multiply by the inverse operations. And right now, this would be 6/1, right? So if I want to use the inverse or the reciprocal of that, I can just say 1/6. And 1/3 times 1/6 is 1/18 of an hour. Now ask yourself, does this make sense? If she only has 1/3 of an hour to share between 6 stretches, we should get an amount that's less than 1/3, right? And if I compared 1/3 and 1/18, 1/3 is greater than 1/18. 1/18 is less than 1/3, right? This you'd share between 3 people, this you'd share between 18 people. So yeah, that's gonna be a smaller chunk, and that would make sense. All right, number 5, Ava has 2 frogs. This is 1/3 of the number of frogs that Heather has. How many frogs does Heather have? Draw a diagram to represent the division. Then write and solve an equation. So the good news is they're telling you that this is division, right? The bad news is, I guess, you have to decide what the order is. And hopefully this diagram would help, right? So it says that Ava has 2 frogs. That's what she starts with, right? So let's draw, I'm not gonna try to draw frogs, okay? Plus, if you have 1/3 of the number of frogs, I don't wanna cut the frogs up into thirds. That just doesn't seem right. So pretend that those are frogs. If you drew frogs, kudos to you, but you know I'm not the artiste. Okay, so it says that this is 1/3 of the frogs that Heather has. So we could cut these up into thirds. Right? And now I want to know how many thirds do I have? Well, 1, 2, 3, 4, 5, 6, right? So there's 6 of them. So what we just did was we took the 2 frogs, and I wanted to know how many thirds there were in 2. So I didn't divide by 3. I want to know how many thirds there are in there. And 2 divided by 1/3, I can multiply by the reciprocal of 1/3, which is 3, and we get 6. So 6 frogs. And think about this, if Ava has 2 and that's 1/3 of the number that Heather has, Ava would have less, right? Because she has less than 1 time the number of frogs that Heather has. And if you divided the 6 by the 3, you'd get the 2 to start. So it makes sense. You could also look at this, just pretend we're in class right now, because I would totally do this, right? If she has 6 frogs and Ava has 1/3 of the 6, then I would want to take these and see how many would be in each if I put them into 3 groups. So this right here, I have 1/3, 1/3, 1/3 of the 6. There's 2 frogs within 1/3 of the 6. So these kind of look a little bit like frogs, right? There's little eyes right there. All right, let's move along. Number 6. For a snack, Miss Johnson gives her class graham crackers. She has a package of 20 graham crackers to share equally among 8 students. How many graham crackers should each student receive? Explain how you found your answer. And we can use math to explain. That is fine by me. So let's think about this. We're sharing equally, right? So sharing equally means division. And what's the thing we're dividing up? We're dividing up the graham crackers. That's what we should start with. So we're taking these 20 graham crackers and we're dividing them up between 8 students. So that should be your division problem right there. 20 divided by 8. And we learned that you can solve this when it doesn't come out. If it was 16 divided by 8, we'd be like, awesome. But it's not. So you can solve this using the inverse of 20 times, this would be 8 over 1, 1/8. And if you wanted to, you could cross simplify that. I'll solve it with cross simplifying and I'll solve it without. So first, I look at the 8 and the 20 and I know 4 goes into both of those. 4 goes into 8 twice and 4 goes into 25 times. So 5 times 1 is 5, 1 times 2 is 2. And then I end up getting 2 goes into 5 twice with 1 left over out of 2. So each child would get 2.5 crackers. Which, does it make sense that I would get less than the 20? Yeah, because the 20 is how much you have total. You're given the total, and we're asked for the part. Now, if you didn't cross simplify and you had 20 over 1 times 1/8, you would get 20/8. And 8 times 2 is 16. 16 plus 4 would get me to the 20. And we know that that 4/8 right there would simplify to 1/2. So you'd still get the same thing if you didn't cross simplify. It's not a big deal. It just makes it a little bit easier at the end. Okay. For number 7, you just have to say true or false for each product. So we want to know if this is what it actually equals. So when I look at this first one, these are all multiplication. So with multiplication, we learned we can multiply across the top, multiply across the bottom, right? And we can do some cross simplifying beforehand too. But as I'm looking, I can't here. And is 3 times 2 21 and 5 times 7 10? No. So this one would be false. For 7b, 2 times 5 is 10, 9 times 3 is 27, so that would make this true. For letter C, 7 times 5 is 35, and 8 times 9 is 72, so that's also true. And for 7D, 1 times 3 is not 4, 1 plus 3 is 4. 2 times 5 is 10, but 1 times 3 is not 4. So this would be false. The answer to that would actually be 3/10. So we're done with number 7. All right, now we're in number 8. And number 8 says, Juan needs to measure 6 cups of flour for a recipe. He only has a 1/4 of a cup measuring cup. How many times must he fill the measuring cup to get the 6 cups of flour? Okay, so what it wants you to do is it wants you to tell whether or not each of these equations could be used to solve that. So whenever I see something like that, the strategy I like to use is I like to solve it and see what the answer is. And if I know the answer, I can look at these equations and see which one of those gives me the answer that I know that it is. So picture this. He needs 6 cups of flour, right? He has a 1/4 measuring cup, so we want to know how many times he's going to have to use this 1/4 to get to 6. So he scoops out a 1/4 and a 1/4 and a 1/4 and a 1/4. So really what we want to know is how many 1/4s there are in 6. And if I want to know how many 1/4s there are in 6, that means I would do 6 divided by 1/4 to get my answer. Now let's solve it, because I know I see 6 divided by 1/4 here, but let's solve it to see if it makes sense before we commit to it. So 6 divided by 1/4, we can change that to 6 times the reciprocal of 1/4, which is 4. And then 6 times 4 is 24. So 24 times, which makes sense because to make 1 cup, wouldn't he need 4 of these? 1/4 plus 1/4 plus 1/4 plus 1/4 is 1. So to make a 1 cup, he'd need 4. To make 6, he would need 6 times 4, which it says right there. So in looking at this, would 6 times 1/4 give me the 24 that I know the answer is? No. If I put a 1 underneath that, that would give me 6/4. And 6/4, 6 over 4, is actually equal to 1 2/4, or 1 1/2. So this is a no. Will 6 times 4 give me the 24? Yes, and that's actually one of my equations up here. That's the inverse of the 6 divided by 1/4. So this is a yes. Will 1 times 4/6 give me my 24 that I know the answer is? No, 1 times 4 is 4, 1 times 6 is 6, and 4/6, I can divide those both by 2 to get 2/3. Definitely not 24, no. 6 divided by 1/4, that is our equation that we used. We already know that gives us 24, so that's a yes. And will 6 divided by 4 give me 24? No, that's the same thing as 6 times 1/4, which is 6/4, which is what we got for that first one that was already a no. So the two that will work are 6 times 4 and 6 divided by 1/4, because those two equations are inverses of one another, and that works with multiplication and division to get the same result. All right, we're almost there. Number 9, Ben has a piece of cord that is 40 feet long. He wants to cut the cord into pieces to tie up the tomato plants in his garden. How many pieces can he cut if each piece is 1/2 of a foot long? Draw a diagram to represent the division. Then write and solve an equation to find the solution. Okay, so it already tells you it's division, right? And we have to think about what we're dividing up and what we're dividing by. And for our diagram, I can check this in during class, but an example of a diagram, I might just, instead of using 40, use an example of 1 foot and then apply it to the 40. So if I had 1 foot of cord, okay, this is just 1 foot. If I want to cut a piece that's each 1/2 of a foot long, that means for every 1 foot, if I cut it in half, for every 1 foot, I would have 2 pieces. This happens 40 times. Okay, so I would have 2 pieces 40 times. And if you have 2 pieces 40 times, I know I could write a multiplication equation for that, right? So we're gonna write both. We'll write a division equation and we'll write a multiplication equation. So what's happening here is we're taking this 40-foot cord, right? And I wanna know how many halves there are in 40. That means I'm taking the 40 and dividing it into halves, right? When you do that, we know that that's the same thing as we saw here, doing 40 times 2. So the answer would be 80. Okay, so he can cut it into 80 pieces. And what we have here is the division equation and the multiplication equation. All right, last one, yay. Of the 5th grade students, 15/20 went to the book fair. Of the students who went to the book fair, 12/16 bought at least 1 book. What fraction of the 5th grade students bought at least 1 book? Well, 12/16 of the 15/20. And we've had enough number talks to know if I want to take a part of a part, right, that word, if I want to do 12/16 of 15/20, this means we're multiplying. You could also think of it of, if these are the number of people that went to the book fair, and 12/16 of those people bought at least 1 book, then my answer should be less than 15/20, right? And in order to get an amount that's less, that would mean I need to multiply by 12/16, because multiplying by a fraction less than 1, as we started, gives us an amount less than what we started with. So whether you took 15/20 multiplied by 12/16 or 12/16 times 15/20 community property, it doesn't matter, you get the same thing. There are a couple different ways you could solve this problem. You'll arrive at the same answer. My guess is that a lot of you looked and you cross-simplified the 12 and the 20. That's my guess. So I'll start with that method. 4 goes into 12 3 times. 4 goes into 20 5 times. And then I'm thinking you probably multiplied those out. 15 times 3, so you could do 15 plus 15 plus 15. Or you could break up that 15 into 10 and 5, and you could do 10 times 3 and 5 times 3. And you get 30 and 15, which would make 45. And then I have 16 times 5. So for 16 times 5, you can do the same thing. We can break up this 16 into 10 and 6 and do 10 times 5 and 6 times 5, and we'd get 50 and 30, and together those make 80. And I'm hoping that you noticed with the 45 and 80, 45 ends in a 5 and 80 ends in a 0. That means that 5 will go into both of these. So we can divide both of them by 5. 45 divided by 5 is 9. And then 80 divided by 5, I would break this one up as well. So like, I know that 5 goes into 50 10 times, right? So I know that 50 divided by 5 is 10. And now from 50 to 80, that's 30 more, right? So now let's take the 30 divided by the 5, and it's 6. So 50 divided by 5 is 10, and 30 divided by 5 is 6. That means the result of this is 16. So 9/16 of the students, that would be our answer. Okay, so 9/16 of the students. Now, another way to do this, both of these fractions are not in simplest form to start. So you could have simplified both fractions to start. So 15/20, don't shut this off yet. If you didn't do this, this is something you can look for. If you have 15/20 times 12/16, I could go ahead and say, okay, well, 5 goes into both of those, and 15 divided by 5 is 3, and 20 divided by 5 is 4. And for 12 and 16, 4 goes into both of those, so divide by 4, divide by 4. 12 divided by 4 is 3, 16 divided by 4 is 4. And now I have 3/4 times 3/4. And 3/4 times 3/4, 3 times 3 is 9, and 4 times 4 is 16. And that's what we just got there. So instead of having to do all of these like big multiplication and division problems, if you look to see if you can simplify things beforehand within the fractions themselves, we can save ourselves some time. All right, that's all I need you to do for today. Enjoy the rest of your day.